Mm. Yes. But in Moodle? I'm in Moodle, I think, but not in Yeah, yeah. This it's difficult to change people in the system. Eventually, everybody will get a grade. As long as you are in Moodle, don't worry. Well, you can ask the lecturer to change you in the Moodle. We are not. I'm not gonna change you again. We just change so that we're the same number. Ask the lecturer. Okay. 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 One, many of you have asked me about the groups, the to move from one group to another. Um, it seems to be that it is a difficult operation in the system for whatever reason. We have made the changes, and you should be on the right model, but you may not be in use space in the right course. So, regardless, if you at the end of the semester, if you do the assignments and so on, you will get a grade for this course, regardless of where you are registered. Okay, so you shouldn't worry about that. The use space system seems to have problems on this with these changes, and at the beginning of the semester is quite difficult to get somebody to help us on this. But we will try to change it throughout the semester, and worst case, by the grading. Are there questions on this? So if you see, as long as you see the right model, you should be fine. Good. So what were we doing? Well, we were thinking about optimal choice. Okay. Okay. Which sort of generally is to find the best bundle given some preferences. Okay, which generally we represent by the utility function and some budget given by prices and income. Okay, and this is, you may be given this and you are asked, to solve this. This would be like you put yourself in the feet of the individual, you solve it, and you find the solution, which we will write as x of p and w, is called the demand function. Okay? We are going to talk about it later. But in general, the solution is the choice. We did an example the other day. Is a choice is that the individual makes as a function of the prices and the income. That's what people call the demand function. The quantity of the goods that you purchase given some prices and some income. And notice that this is a quantity for each of the goods, right? So this is a vector, x1 and x2. Okay. Now, I also want to make clear that, of course, this is an interesting problem. Of course, you can think of, if you have this information, what would you do? And this is part of what we want to do. But we also actually, as I try to say all the time, what we actually observe in the real world is this. Okay, we hope to observe demand. By observing choices of individuals at different prices, we hope that we can recover demand. Okay? We see these choices, and then a natural question is to see what can we say about people's preferences and so on if those choices are consistent with their preferences. So one thing that we already used was warp. And you will see in the problem set that that is assigned in the Ubuntu, but for those of you, it's also uploaded in the main course Moodle, but you don't have to submit any solution in the main course, only in the Ubuntu. For some problems, you are given something about the demand, and maybe you are asked something about the utility function. Although this is kind of a reverse problem, because usually we do this. This is the natural problem because this is what we do see. And then we want to know something about, what does this tell us about the individual? The individual buys a lot of this product. What does this tell us about the preferences of this individual? Okay, the individual buys a lot when the prices are low, but very little when the prices are high. What does this tell us about the individual? Okay, because then we can maybe perhaps change the prices and the income, okay, and get a different choice. And, to some extent, the individual will be maybe better, maybe worse. Okay, so some problems will be of this form. For instance, the ones you solved today, they were in the Ubuntu, they were the simplest problems. They are all of this form and very simple. Some problems are more complex because they require basically you thinking when you are giving choices, okay, and thinking how to what does choices tell us for the individual. We'll do an example later. Okay, so in addition, the other thing that you will see in the homework, and when I talk about the homework, I'm always talking about the exam because the homework problems are really exam problems. Okay, is that the framework is often the same framework, but there are various different examples, and each of the examples has a little bit of particularities, and one needs to, of course, think, because that's how we apply economics to different situations. We know the general rules, but we also want to understand the specificities. And we already did 2 examples last week, one with an investment problem and one with a labor supply or leisure labor choice. And we are going to think about other examples today. Another example now, which is the gambling problem, okay? So in this case, Bob is a gambler. He likes to play the slot machines, although he knows this is bad for him. Okay, so although we are not going to do much of this during the course, only at the very end, here are going to be allowing for Bob to have choices that he may understand are not the best for him. So I'm going to allow Bob to be not rational, okay, in principle. Because a lot of people who gamble because of addiction and other problems, they may not be really able to fulfill their true desires in some sense. So what happens in this gambling problem in the slot machine is that if you put 10 euros, you get back on average 5 euros. This is in general what happens in the slot machines. You put money in and some money comes out, but there is always less money coming out unless you are very lucky, okay? Everybody's thinking they are very lucky, but on average, the machine only gives like 50. In reality, I think it's 60%, but let's just have it at 50. His daily budget is 50 euros. That's his budget for every day, what he can spend. Here, the term budget just means what you would use it for. It's like the amount of money you can spend, not what I meant usually, which is the set of bundles that you can afford. And the question here is, first of all, what does this person want? Well, he presumably spends money on other things. Let's call that generally consumption, and gambles, okay? And the money he gambles, in principle, some of it comes back, some of it are lost. That's right. So how much the first question you need to figure out is what is this budget line? And to answer the budget line, the typical question you ask yourself is, what is the most he can spend of each of the goods? And clearly, the most he can spend of consumption is 50 euros. Because if he doesn't gamble at all, he has 50 euros, that's the most he can consume. So 50 units of consumption. And consumption in economics is typically measured in the currency. So if you have 50 euros, how many units of consumption? Typically 50. Equivalently, you can say that the price of consumption is typically 1. So what happens with gambling? How much can he gamble at most? How much can he gamble? 50? Okay, 50, and what happens after 50? That doesn't matter. Suppose you put 50 euros in the gambling machine. How much in the slot machine? How much you get back? 25. What can you do with that? You can put it again. How much does come back? 12 and a half. How much comes back? 6 something, yeah? So how much is that in total? Okay? It's 100. Okay? There are different ways to find that it is 100. You can think of it as an infinite sum. 50, 25, it's always 1 over 2. So it's 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 is approximately 2. Another thing is, if you think about it, For every, I forgot, there are many ways to compute it. Yeah, that's, to me, that's the easiest. I forgot. There is another way. I think people find it easier, but I forgot. So the way to think about the way I think about it is you put 50 times 1, then half of it comes back, then half times half, then half times half times half, and this is 100. Okay, this is 50 times the sum of 1 over 2 to the power n from 0 to infinity is 100. Ah, sorry. It never reaches 100. Yeah, it converges to 100. Yes, converges to 100. He will have to play forever. Probably doesn't have time in one day to get to 100, but he will be very close. Okay. And so what really tells you this is, sorry, the slope, of course, is, this is what is important for him. The slope is, what is the slope? What is generally the slope? The price ratio. What is the price of consumption? Hmm? What is the price of consumption? I said before. Price, not quantity. What is, how much, 1 unit of consumption, how much costs? I said before, for consumption, usually we always have the price of 1 because consumption is measured really in money in some sense. Yeah, is what you can buy. How much consumption can you buy with 50 euros? 50 euros. Okay. Gambling, what is the price of gambling? What is the price of gambling? If you put 50, how many units you get? Huh? If you put 50, if you devote 50 euros of your income to gambling, how much you gamble? How much can you gamble? How much can you afford to gamble? 100. What is the price? Half. What is the price ratio? 1 over 1 over 2 is 2. The price ratio is 2. Okay? The slope of this line is minus 2. Why? If I can choose, the relative price of consumption is, for every unit of consumption, I lose 2 units of gambling. I can gamble twice. Okay? It's very tempting because for every euro that I save from consuming, I can gamble 2 euros. If the rate is 60 like it is actually closer to 3 euros. So it really makes it a bit more attractive than you would think. Okay, that's the first thing. The second thing is, as I said, it could be that this guy's well-being is represented by the blue line, by the red line rather than the blue line. The blue line is what you would call his choice utility. It's a bit weird concept. It's the choice utility. It's the utility he shows me when he chooses. But he may be, in this case, a bit, it's problematic for him to choose because he's addicted to gambling. He knows that what he would like to have in life are things according to the red preferences. Okay? But he chooses according to the blue preferences. In the blue preferences, the marginal rate of substitution everywhere is flatter, meaning the marginal utility of good 1 relative to good 2, consumption relative to gambling, is lower than under the red line. In the red line, consumption is worth relatively more. You need more gambling to be just as happy. Okay, and now you can ask the following question. This is a policy question: is banning gambling would be good for him? Okay, would he be willing to accept a world in which he cannot gamble? Okay, in which he cannot gamble. What do you think? You don't know? Suppose I give you this information. The red lines are, as I said, his preferences, true preferences. The blue line is what happens when he's in front of the slot machines. So the blue line is him addicted, but the red line is what he really when he's at home, he's telling his family, I would really want to be red, but I cannot. Okay? So now you see these preferences, and what do you think? Does he want to gambling to be banned because he's tempted to gamble too much, or does he prefer gambling to exist? Okay, first of all, we cannot make that argument because he's not rational. No, that's an important point. This because indeed that's the difference. When you give up rationality, you cannot make arguments. He would have done this, which is in general true. Nobody benefits from banning something they would be choosing because they could just not choose them as long as they are rational. But if they are not rational, this can happen. I can show you another picture where this would happen. But you are right with the answer in the sense that this is the choice he makes when gambling is legal, right? Because this is when he goes to the slot machine, he ends up here. Is this better or worse than banning gambling according to his red preferences? Of course, it's worse than what he would ideally do. That's clear. But is it better or worse than banning gambling? They intersect, but they are in a sense different people. Okay, let's explain this a little bit slower. So we have an individual, forget in a sense about the blue preferences. What we know is that this individual faced with these choices chooses here. That's what we see. And we also know that he told us that actually he would like, these are his preferences. Okay, these are his preferences. That's what we learned. We learned that he chooses here, and given the conditions, this would be what he would like to choose, but he cannot because he cannot commit. He doesn't have self-control. He cannot stop himself from gambling. And the preferences are such that there is this other indifference curve down here. Okay? So this is what we know about him. And I'm asking the question, should we ban gambling? What happens if we ban gambling? What happens? He only consumes because gambling is illegal. In a country where gambling is illegal, nobody gambles. Okay? Some people gamble, but he wouldn't. Okay? So it's just this point. And now what do we know about that point? Yeah. It's worse than the other. It's there is an indifference curve that goes through this point and is better than the banning. Banning is bad. Okay, banning is bad for him, although he doesn't like to, he is unhappy with his choice. He would like to gamble less, but he wouldn't want to gamble so little. He wouldn't want to gamble so little or nothing. Okay, so banning gambling is not good for him. On the other hand, you could write the picture so that I show you that this is no longer, of course, you cannot use the argument that he would have chosen because he is not rational. He would like this point, he chooses this point, and now if his preferences were like this, now what? If these are his preferences, should we ban gambling here? What do you think? That's right. So he can choose what he truly wants. He ends up choosing this point, and this point is worse than the point down here now. And the point down here is what he can choose in a world where gambling is illegal. Where gambling is illegal, he no longer goes here, but here, so he prefers this one. So you see, you cannot use any more reveal preference because the individual does not show us with his choices his preference. His choices are unrelated to his preferences. That's the twist. When you have behavioral individuals, you can no longer say, if I see somebody doing something, it must be that's good for them. Maybe they are doing something that's not good for them. And in that world, for instance, banning things or taxing things like sugar, tobacco, alcohol, and so on, makes sense because individuals maybe, at least that's the story, would like to do less of that, but they are somehow addicted to it, and they may benefit from the fact that they can't do it. Okay. Notice that banning gambling is just putting a tax of 100%. Any money you put to gamble disappears. It's equivalent. Nobody would gamble if you have a 100% tax. Okay. So more generally, you can have a different tax. So in this case, you have some tax, and so the price changes. Why? Because every euro you put in the slot machine, some of it comes back, and some of it comes back to the government. The government is also there collecting with the glass, the coins. Okay. So instead of having a price ratio of 1/2, we have a price ratio of what? Sorry, the price ratio before was -2. This price ratio is 8/5. Okay, doesn't really matter very much, but it's 1.6 is less than 2. Okay, the slope is flatter. Is this person richer or poorer? Is she richer or poorer? Poorer, because they tax. Nobody likes to be taxed. Okay, well, this person may like it, but she is poor. Anyhow, she's poorer because any bundles that were available to her before, they are no longer available. What did we know about these people? When you are richer, you can afford things that you couldn't before. You must be better off, right? Because you could achieve something that you couldn't do before. And worst case scenario, you can choose always this point as before. Well, this need not apply to this individual because she is not rational. So in this new problem, she may choose different than in the old problem. Okay, so how do we know whether she will be happier or not? Okay, look at this bundle here. This bundle here crosses the initial choice. Okay, and it's on the budget line. And the new budget line. It crosses the initial choice and is on the initial budget line. That means if the individual chose this point in particular in the new world, so if his blue preferences were tangent here, okay, if the individual chose this blue point, then he wouldn't care. The tax would be just as good as no tax. If he gambles more, meaning he lies to the right, he's going to be under the red line, so he's going to be worse than before. And if he is to the right of the blue line, so a point like this one, he actually would benefit from the tax. Because the tax would make gambling so unappealing that he would be able to control himself, and by controlling himself, he actually would be happier. Again, this can't happen with a rational individual. But with an irrational individual, you can have that people benefit from being taxed. It can happen that people benefit from being poorer. It can happen that people benefit from being named things that they are doing illegal. It's completely different. But I just wanted to, highlight also with this example the power of rationality. Because once you have rationality, all these things can't happen. They just can't happen. An individual who is rational would never benefit from taxing, could never benefit from banning, would never be better off from being poorer. Okay? But an individual who is irrational or has some, failures of rationality, then may. Questions on this? Okay. Okay, so we did all this. And as I said, the solution of the maximization problem for arbitrary prices and income is called the demand function. And in this course, we call them usually either Marshallian or Walrasian demand functions. Okay? They are demand functions. They are functions that tell you for every price vector, in this case, we have two prices, but in general, an income, what the individual wants. Okay? And these are the individual demand functions of this person. Usually in economics, we talk about the demand function, meaning the aggregate for the whole economy somehow, with the society as a whole. That's just we're going to see later, but that's just the sum of the individual demand functions. So if I demand 3 units and you demand 2 units and the other guy demands 4 units, the total demand is 9 units. Okay? That's nothing different from this. This solution has some properties. First of all, it exists, which is great, because if it didn't exist, it would be problematic. It's just a mathematical connection because observation, because you are maximizing a continuous function. The utility function is continuous on a compact set. Okay, so this is marked by a linear inequality, so it's a compact set, and the theorem of maximum guarantees that a solution exists. The solution can be interior. Interior solutions, we already discussed them, satisfy the first order conditions. So in this case, I'm just doing a representation with one variable. That just means that the slope is 0. But in general, this means that the first order conditions are satisfied with equality. And there is also this corner solution that I told you. What happens when the individual buys 0 amount of one of the goods? Well, in that case, it could be that the marginal utility of this good does not satisfy the condition with equality, but with inequality. Okay, but that's not so important. There are 2 cases: interior solution or corner solution. Okay, the second part is that, generally speaking, we have preferences you have seen typically, which are strictly convex. Okay, what does it mean strictly convex? Well, if you look at an indifference curve and you take 2 points of this curve and you link them, right? And you link them, so you think about 2 extreme bundles, bundle A and bundle B. In the example of the gambler, bundle B is a bundle with a lot of consumption and little gambling. A has a lot of gambling and not much consumption. Well, if the preferences are convex, the individual is happier. The individual is happier in the average bundle, where you have a balanced amount of both goods, an even amount of both goods. Okay, some people talk about this being related to people's additional utility from goods being lower and lower, but that's not very precise. Okay, it's just this preference for balanced baskets. You don't like extremes, you like balanced. Okay, in general, other things equal. And this means that actually the demand is a function, meaning there is a single solution for every problem. There are not multiple solutions. There could be multiple solutions if this is not satisfied, okay, if this convexity is not true. And the other property that you should remember, or everybody should remember, about the demand function is so-called money, what I call here money neutrality. Okay, or it's just the fact that if I change the currency, the solution should not change. So if I ask you, this is your income, these are the prices, and this is Vienna, and then everything is in euros, and you give me a solution to your problem, you tell me what you should consume, and then I change the currency, and I go back to the shilling, or I ask you everything in dollars, and I adjust all the prices, nothing should change in your solution. Okay, and the reason is mathematically very simple. Well, your budget, your preferences, so your solution, you have a problem like this, your solution can change because your preferences change. Okay, your preferences change, you change your solution, or because the budget changes. Two reasons can bring a change in your solution. Now, if the currency changes, should you change your preferences? No, your preference should be the same. So the only thing that can change is the budget set, the set of available options. But will the set of available options depend on the currency on which you are paying? When you are in somewhere and they tell you, which currency do you want to pay? Like sometimes with a car, maybe if you buy a plane ticket, it should be that what you can afford is the same no matter which currency you use. I mean, there may be some differences, very small in reality, but in general, there shouldn't be differences. And how do we see this? Suppose that X is affordable. Suppose that X is affordable. Okay? What does it mean that it is affordable? It's on the budget set, so mathematically, how would you explain this? Huh? What does it mean that it is affordable? Nobody? How would you write it down? You would write that P1 times X1 plus P2 times X2 is affordable, so it's lower or equal than W. So suppose that we move to another currency, and this other currency, 1 euro is theta dollars for some theta. Theta is some value, okay? So if the price is P1 in euros, what is the price in dollars? Theta times P1. Why? Well, suppose theta is 2, right? If theta is 2, 1 euro, $2. If something costs 1 euro, $2. Okay, so theta times P1, X1, plus theta times P2, X2, must be smaller or equal than what? Theta times W, because my income is also multiplied in this new currency. Okay, and what happens here? It cancels, yeah, because it multiplies everywhere, so it cancels. So it doesn't matter, okay? So the budget doesn't change, the preferences doesn't change, your solution doesn't change, okay? This is sometimes called money neutrality because the actual amount, the actual currency doesn't matter. Is this true in reality? No. Okay, there are many examples for people that actually they are subject to something is called money illusion. Okay, money illusion. The actual amount matters. One example you see in the supermarket where the actual amount of the prices matters, the exact amount. What do you see sometimes in the supermarket? 99 cents, exactly. So people buy more at 4.99 than at 5 euros, right? 4.99 looks less. Okay? Why is this a violation of money illusion? Well, because the difference between 4.99 and 5 is not the same as between 5.01 and 5. That difference, the difference in difference, if you want, the change that is very big between 4.99 and 5 and very small between 5 and 5.01, you never see prices like 5.01 in the supermarket. But if they were there, the same people would buy at 5 than at 5.01 because it's roughly the same price. But many more people buy at 4.99. Okay? So they keep it the price at 4.99. And if you change the currency to a very similar currency, in that currency what was 4.99 is 5, and what is 5 is 5.01, you see that the demand is different, the choices are different in the world of 499.5 than in the world of 5501. Okay, so of course, I mean, I'm not saying that this is so important, but you know, almost everybody who ever worked on a shop knows that this matters, okay, at least to some extent. At least to some extent. Okay, this is what we just did. Questions? Okay, so we already did the other day, the example is here. We did a simpler one, but it's not so important. I'm going to do this one as another example of how to solve a problem like this. And then I'm going to talk a little bit more about the solution and a few other things. Questions? Okay. So suppose you have, this is a very classical example, it's called quasi-linear utility. Okay. U is, in general, is going to be some function, which in this case is the logarithm, is the easiest, but it could be some other function of x1, of one of the goods, plus x2. Now, this utility function is very popular because it treats one of the goods linearly and treats the other good non-linearly. So the good they treat linearly, you can think of as a summary of all the other goods. Why is this the case? Well, all the other goods are such that you have so many options that consuming a little bit more or a little bit less is always going to be just as good. Okay, in the sense that it's going to add the same amount to your utility. While the good that you are focusing on is a single good, for instance, potatoes. So if you can consume a few more potatoes, kind of the marginal utility of potatoes starts going down, while the marginal utility of everything else is more or less constant. Okay, so that's why people use this quasi-linear utility, and it's used very much in almost every application that you would think they have some version of the quasi-linear utility. Okay, so how do we max? So you want to max it, and you have a generic budget. Sometimes P2, the price of the quasi-linear good, because it's every other good in some sense, is always 1. But in this case, we are not going to enforce that. It can be anything. Okay, so we maximize this subject to this budget line. And the first order condition is, what is the first order condition with respect to x1? Huh? What is the derivative of the utility function with respect to x1? Okay, let me write the Lagrangian so that maybe helps you. Is log of x1 plus x2 minus lambda p1 x1 plus p2 x2 minus w. So what is the first order condition with respect to x1? 1 over x1 minus what? Lambda p1. Okay? And let's assume, and then this will be equal to 0. Why? What happens here? Well, x1, if x1 is 0, remember, this is equal if we are in the interior. And in the interior is true because if x1 is 0, how much is this number? Infinite. This can happen. So it has to be finite. So you know for a fact that you buy good 1. What happens with good 2? Well, the first order condition is what? 1 minus lambda p2. Well, is this thing equal to 0? I don't know, because this is a number and this is a number. So maybe they are equal to 0, maybe not. I don't know. So I put an inequality. Okay? I put an inequality because I don't know. Okay? Intuitively, you can guess the following. If you are rich enough, as you increase x1, what happens with this? When you increase x1? This falls, okay? So eventually you are going to hit that number, whatever that number is. And then you are going to start buying this number, okay? Okay, this is the first order condition. Alternatively, we can go back to the marginal rate of substitution. Now, I'm going to assume the marginal rate of substitution, as I said, there will be two cases, but I'm going to assume that the solution is interior for now. So suppose that it is interior. Okay, so it's with equality. And this is what you usually do. You assume it is interior because it's the simple case. And if it is not interior, it's clear what happens. What happens if it is not interior? What happens if the solution is not interior? Can this be 0? We agreed no, because this is infinity. So this must be 0. So you are done. Okay? So the first order, the problem is quite simple. We assume it's interior. We see if that makes sense. And if it doesn't make sense, we know what happens. We buy nothing of good 2. Okay, so the marginal rate of substitution, if it's interior, is what? How do we get it? We divide one equation by the other, equals to, sorry? Well, yeah. No, but this must be equal on the other side to what? To P1 over P2. Okay? So this gives us a number here. This gives us x1 equals P1 over P2. P2 over P1. Okay. Is that the demand function? Is it or is it not? Does it depend on prices? Huh? The demand function, we saw it before, we are looking for the demand function x of P and W. Prices and income. Does this depend on prices? Does it depend on income? No. Well, a function doesn't need to depend on everything. It's enough that it doesn't depend on things that are not part of the function. So in this case, it depends only on things that are listed in the function, P2 and P1. So that's good. But income is not there. Why income is not there? Because this is the case in which there's the allocation if it is interior. If it is not interior, you may not be able to afford all this amount. So for instance, suppose that income is 10, P1 is 1, and P2 is 20. This solution is what? It's not a solution because it's not affordable. This person would like to consume more of X1 than he can afford, which everybody wants to consume more of X1 than they can afford. That's nothing surprising, okay? So in that case, we have a corner. So when do we have a corner, really? When do we have a corner? When X1 times P1 is already, let's call this tilde, X1 times P1 is greater than W. When this happens, this amount that we want to buy of good 1, we can't afford. So what does this mean? P2 greater than P1. If P2 is greater than P1, and than W, sorry, not than P1. If P2 is greater than W, you can't afford the allocation that you would like to buy. So your demand is equal to P2 over P1, so this is X1 of P1, P2, and W, is P2 over P1 if P2 is less than or equal to W, and W over P1 if P2 is greater than W. This case is the corner, and you buy all your income, you put all your income on good one. And if you can, if P2 is lower, you put only P2. Okay? Okay? So this is it's kind of a tricky case because there is this corner you have to carry, but otherwise it's very simple math. It's just you need to always do the same way. You assume the location is interior, and if it is not interior, you are going to see it because you can't pay for it. Okay? And that's how you solve these problems. You first assume it is interior, you do the marginal rate of substitution, you will get an equation like this, and then you just figure out whether you can pay for it. Okay? What is X2 of P1, P2, and W? How much you consume of the other good? How much you consume of the other good? If P2 is less than W, if P2 is more than W, how much you consume? 0, because you put all your income on good one, so bad luck. You don't buy good 2. And if P2 is less than W, how much you put? Well, you have, let's see, X1 P1 plus X2 P2 is W. X1 is what? P2 over P1, because we are in this case, times P1 plus X2 P2 is W. So this cancels. So X2 is W minus P2 over P2, or W over P2 minus 1. Okay? So when that P2 is greater than W, this number would be negative, which we can't afford. Now, some people in the quasi-linear model, they say, well, X2 is actually any other good, and you can't even go negative because it's just like money. And you could have negative amount of money. Okay? So some people even forget about this case by saying that you can have negative amount. But in this course, we won't do that. But you would see this in some books. Okay? So in this case, you can have an interior solution. And when you have an interior solution, the amount of X1 is always the same. Or you have a corner solution, and the amount of X1 is different. Okay? So you can depict here, this is P1, and this is X1 of P1, P2, and W, your demand. You can depict it. How does it look? How does this function look? So this is P2. So let me see. This is P1. So this is when, let me do an example. Let's say that W is 10. Okay, let's say that W is 10. And that's P2. So that's P1 is greater than P2. No, that's, sorry about this. I'm thinking if we can depict it like that, because it depends on the other numbers. Okay, so P2 is also, P2 is, let's say that P2 is 5. So how does this look in this case? Well, in this case, P2 is 5, is less than 10. So the demand is just like this, okay? It's just 1 over P1 times, this is P2, this is 5 over P1, yeah? And if P2 is 20, okay, if P2 is 20, you always buy all your income of P1, so your demand function is 10 over P1. It no longer depends on P2, it just depends on W, okay? So this corresponds to this. and this corresponds to this. Okay, doesn't really matter so much. It's just one example. Okay. The last thing we want to talk about demand is that you can use the demand functions x1 of P1 W, P2 and W, and x2 of P1, P2 and W to come up with the indirect utility. The indirect utility function is another function that we can compute, which is basically what you get from plugging into the problem, the demand functions into the utility function. So if you plug in the demand functions into the utility functions, the demand functions are a function of the prices and the income. Okay, the demand function are a function of the prices and the income, and the indirect utility function is also a function of the prices and the income, because once you replace it, it's the same thing. And it tells you what? It tells you the level of utility that you can attain when you face a certain problem. It tells you for this individual some measure of how happy he is or she is or they are when they are facing a particular problem. A particular problem meaning a particular vector of prices and income. It's a measure of well-being. Okay? It's a measure of well-being with the idea, remember that utility is only ordinal, it's just beta, it's just about whether it's better or worse. So you are better if your indirect utility is higher, and you are worse if your indirect utility is lower. In the slides, you have it for the utility function we computed the other day. Okay? But today I'm going to just do it with this utility function. So let's see what our indirect utility function is. So again, think about the problem, you have the solution, you have the preferences, and these preferences correspond to some level of utility I naught. So what is telling you? It tells you that P1, P2, W over P1, W over P2, the utility associated with this problem is 0, I naught. Is the utility that you can get in the optimal solution. Okay? So this just tells you, for this individual, this problem delivers this utility. And if you change the prices and the income, now you can ask, is the individual better off or worse off? Of course, depending on the problem, you can tell this already from revealed preference, but in some problems you cannot, but you could if you know the utility function by looking at the indirect utility function. So let's compute it for this example. I think it's just best if we just do the example. Okay? So in this example, x1, let's assume first that is interior. Okay, is interior. X1 of P1, P2, and W is P2 over P1, and X2 of P1, P2, and W is W over P2 minus 1. So what is the indirect utility function? Is the utility function in which instead of x1, I have the demand of x1. And instead of x2, I have the demand of x2. So what do I have first? What is the utility function then? Huh? Beta, this is the logarithm. And probably I wrote this very ugly. It's the logarithm. I don't know. Maybe this was not clear. It's in the slides, okay? Everything is in the slides, but it's the log of P2 over P1 plus W over P2 minus 1, because this is just x2 and this is just x1. Okay? So this is the indirect utility. This tells you, well, what matters for the individual. Notice, first of all, this minus 1 is not really relevant because everybody has minus 1. That's not relevant, okay? So this doesn't really matter. What matters is when you compare are the prices. So the ratio of prices is, the ratio of the log is what? Is the difference of logarithms, okay? Plus W over P2 and minus 1, okay? So what matters for the individual is the difference in the logarithms of the prices, for this example, for instance, and the real amount, the amount of good two that he can afford. So this individual compares problems based on the amount of good two that he can afford and the logarithm of the difference of the logarithm of the prices. Okay? So if you fix the amount of good two that he can afford, because remember, good two is consumption, so if P2 is 1, and this we call a normalization sometimes, you will see. If P2 is 1, then this is just W minus the log of P1. The log of 1 is 0 minus 1. Okay? So in that case, the individual cares about his wealth. Of course, more wealth is better. And the prices, simply the log of P1. Okay? That would be how he would compare the utility. If you give him one more unit of W, you can increase P1 so that the difference between, so the log increases by 1. Okay? When does the log increase by 1? The log of something increases by 1 if? Suppose I double a quantity. By how much does the log increases? If I double a quantity, by how much its log increases? Okay, this is very important. If you have the log of 2, or the log of 4 is the log of 2 times 2, okay, is the log of 2 plus the log of 2 is 2 times the log of 2. Okay? The log of the product is the sum of the logs, meaning if you double, so this is not so good. If you double the thing, let me do it. The log of 2x, sorry. The log of 2x is the log of 2. That's what is the difference. Is the log of 2 plus the log of x. Okay? So if I double a quantity, it increases by a fixed amount, which is the log of 2. Always. Okay? This was not so clear with 2, but with any other quantity, it increases by the log of 2. The log of 2 is 0.7. The log of e, the number e, the log of the number e is 1. So if I increase W by 1, I need to more than multiply by 2 the price. Okay? Doesn't really matter, but you should know that this you should know, okay? That when you double a quantity, its log grows by a fixed amount. When you multiply by 10 a quantity, its log grows by a fixed amount. Not by 10 times, but by a certain amount, a number. Okay? Doesn't really matter for this, but in general, it matters. So this just tells you how you compare problems. The individual is happy when W is higher minus the log of P1. So when the P1 grows, of course, he's unhappy, but what matters more for him is W, not the log of P1. Yes? Yeah, because I call P2 equals 1. So I said the good 2 is any other good. So let's call it consumption. So I eliminated P2 because it doesn't really help us. So let's just call P2 equals 1. You will see in the course that we will do this sometimes. This just says I'm calling the prices in units of good 2. Okay? So if good 2 is any other good, that makes sense. It's money. If P2 is I don't know, chicken, it doesn't really make much sense. But if P2 is any other good, it makes sense that we call the price of those goods 1. So this is just by equal, I mean fixing P2 equals to 1. Very often you will see we can set one of the prices equal to 1, which is convenient, like here. Okay. You have another example. I'm not going to do it. I just want to talk about 2 things and we're gone and we finish these lectures, okay? Right. So as I told you, most of the time in economics, you don't deal with the individual demand function, okay? Because you have a single individual, it's hard that you have a lot of data on this one individual. It's also unlikely that you care a lot about this one individual. Usually we care about more people than one person, okay? And so what we typically get is the aggregate purchases of a collection of individuals, okay? That's what we typically see. So you see the aggregate demand that depends on the prices and the income of people. Okay? The prices are the same for everybody, but of course the income levels are different. Okay? And so we get this object X of P and W. And many people have thought about the question, does this object X of P and W look a little bit like the object we derive here? And the answer is no. It looks nothing like it. Okay? In general, for instance, even if each person is rational, the aggregate of our choices are not rational. Okay? As if there is no single person that could be behind those choices. Because indeed, we are not one single person. We are many different people. So it's not so surprising in a sense. Okay? What does it mean that the aggregate demand satisfy means warp? It means that all of us act as if we were a single person. As if there is a person behind us who is pushing, is trying to achieve something with all our choices. But there is not such a person. We are each of us choosing on our own. So in a sense, it's not very surprising that aggregate demand does not satisfy warp. Because warp would mean is as if there is some person out there whose objective we are all together collectively maximizing. And that is unlikely. But that is assumption, and you've seen this for sure in macro, when people talk about the representative agent. Okay, you heard of this representative agent. The representative agent is some person is as if we all are choosing for this person, this representative agent. Okay, that's very restrictive. It can happen, but roughly it may be requiring that all of us have the same utility, which is incredibly unlikely. Each of us have a different preference. Okay, so it's important to remember that in economics, the aggregate, this representative agent that most models have, basically requires that we behave in a very that almost all of us have the same goals. Okay, that doesn't happen. How far is the reality from that? There is a lot of discussion on that. Many models now have heterogeneous agents. They are called heterogeneous agents models, in which each person makes decisions differently than the others. They have different preferences. But in the typical world of representative agent, is as if there is this one person who is behind all of us, and effectively requires that they have the same preferences. Right? There are some cases that they actually not so restrictive, but doesn't really matter. Okay, I have here an example. For instance, you have an economy with two goods, goods 1 and 2, and good 1 is intensive in CO2 and good 2 is not. Okay, so good 1 is, I don't know, transportation. You need to burn gas to make transportation. Good 2 is, I don't know, some I don't know what good is not intensive in CO2. Probably relatively, all of them have some CO2, emit some CO2, but relatively less. Okay, food, but I mean veggie food or something. Every individual has preferences U of X1 and X2 and income WI and total income is W. And we are interested in understanding, this is something that people care a lot about. This is an example is not so stupid because out there is a lot of debate about the relation between inequality and emissions. Because it usually is the case that lower income people have a balance, baskets buy things that have relatively more or less CO2. What do you think? Huh? Typically, they buy baskets that have more CO2. They use more. That doesn't mean that they pollute more. They pollute less, but as a proportion of their income. That's what it means. As a proportion of their income, they usually spend more in CO2. This is not because they like to pollute, but because they buy different goods. And so many people, when talking about green taxation and carbon taxation, they are concerned that the weight is going to go disproportionately to poorer people. Okay? So this is really a question many people have asked. And the answer depends on whether people's preferences are so-called homothetic. Okay, there are examples here you have of these homothetic preferences. Homothetic preferences say your consumption of the goods is going to be, as a proportion of your income, is going to be the same no matter whether you are poor or rich. Okay, if you have these homothetic preferences, poor people and rich people have the same proportion of their income spent on CO2, while if you have non-homothetic preferences, which are the other ones, for instance, this one, the individual actually who is richer buys relatively more CO2. It has a higher emissions on CO2. Okay. In this case, this is an example that you will see also in some of the homeworks. This utility function is similar to the Cobb-Douglas, where you have X1 and X2, but you have this component in between A. And A is like the minimum consumption. So what happens here is to live, you need to burn some coal. If you don't burn coal, you don't live. But then as you are richer, this doesn't matter anymore. What matters is the other thing. So people who are richer will buy relatively less, proportionally less coal. When you are poor, you spend almost all your income on surviving, and to survive, you need to keep some coal, okay? Maybe for heating or something like that. But as you are richer, you care about the other good as well, good 2, which has less CO2. So this is a simple way of introducing this sort of so-called non-homothetic preferences. And in this case, rich people would buy less, would pay less, would consume less CO2, and more inequality would, with inequality, people would actually, poor people would suffer a lot of the CO2 tax, and rich people suffer relatively less. Okay. The last thing I want to say, and by the way, remember I told you, I think everything that is in purple, these are additional examples. This doesn't mean that it is not important, because many of the examples you will see in the homeworks have this type of flavor, in which you need to reason things like this. Okay? But it means that you don't need to learn this in any way. These are just examples. Okay? Everything that is in purple is just examples. But if you practice these examples, you are more likely to answer correctly. Okay. Now, the last thing I want to say, this is not an example. This is kind of a digression or a discussion. In this course, we will use the math, a very simple, from a very mathematically, very not sophisticated way, but still, we are going to use the traditional way in economics of thinking about problems from a formal logic, and in particular, individual's choice problem becoming a problem of maximizing something given constraints, constraint optimization problems. The advantage of this is that, first of all, these problems are extremely nice and tractable. So when I ask you, solve me the demand function, I'm asking you to choose among all possible bundles that exist, the one that is best for the individual. So you have a lot of choice, and you can find right away one single one that is the best. With a couple of operations. You see, in this example, we basically did a couple of operations, we got a solution. That's amazing, okay? Most problems in life you would write down, they look very complicated. These problems are relatively very simple. It's a couple of steps and you get the solution. I wish all problems in life were like this. You do a couple of steps, you get the solution. The problem, as we saw, allows us to do comparative statics. The other day, we did the comparative statics graphically, and today we did some comparative statics with the indirect utility function. These comparative statics, remember, changes in the parameters, how do they change the solution? In this case, we look at the indirect utility function, telling changes in the parameters, how do they change my utility? It is extremely flexible. We did already 3 examples of problems in economics that have nothing to do with each other. The problem of the investment, the problem of the labor decision, the problem of the gambler. Any other problem we look about, apples and bananas, but also problems I told you at the beginning, things about which, where should you live? Questions about how many children should you have, things like that. People have incorporated this way of thinking into those problems as well. Okay, it's extremely flexible, and it has led to economics being very invasive and going into problems that are not really economics. Okay, because this technique is so powerful that you can basically ask yourself, how, if I use this technique, what is the answer to many questions? And it is very parsimonious. What does it mean, parsimonious? There are very few elements. They really tell you that the problem does not depend on your... In economics, we have a very parsimonious model because we eliminate many things that really do not matter. The currency. We don't tell you what is the currency because the currency doesn't matter. We don't tell you whether you buy to the supermarket or you buy in an auction or in the market in the corner, or whether you go to the farmer and you buy it there. It doesn't matter. We don't really talk about whether your income is, where does it come from? Because for this problem of choosing between these two things, it doesn't matter. So really, it eliminates things that are not relevant. It's very parsimonious. It's very few things that really mean something to the problem. Okay? And it produces sort of empirically valid predictions, which very often are just qualitative in nature, meaning if you increase the price, you should expect this and this and this to happen. It's not a natural science that's going to tell you, exactly this will happen, but it generally predicts in the direction that and can be tested in that way. Okay? So these are the reasons why we use this. These are the reasons that people like this. There are good reasons. There are, of course, many reasons not to like it. Okay? Not in this course, we like it, but there are many reasons not to like it. Most likely, I've been telling you all the time that people really don't follow this. So it's a very good approximation, but it is not precise in that it doesn't represent what people do, because people really fail to use this. Now, there is a highbrow type of people who say, well, it's their problem. If they don't follow it, they should, so their problem. I don't care. That's not really true, because we care to try to understand what people do. And so most of the time, it's a very important question whether our models will be close or not. Sometimes they are going to be close because we are going to be able to introduce easy changes, easy fixes. For instance, in some of the models, we introduce noise or optimization errors, small mistakes, and this works quite well when those mistakes are not very systematic. Okay, so for instance, maybe I am biased for this $4.99 price I told you before. I shouldn't buy so much at $4.99, but I end up buying at $4.99. Well, that's really almost like noise. Okay, it's almost like an error. It's not a big deal, depending on the question you want to ask. If your question is about pricing in the supermarket, then it's not noise, but on the aggregate for other things, it's almost noise. Okay, and there are many models like that. They are called bounded rationality. There are learning models. There is a whole world of models that include these things. Inattention is the most famous one nowadays. In the inattention world, it's like when you go to the supermarket, you're supposed to look at the prices, but I bet you pick many products without looking the price. You more or less know how much they cost. You typically buy it. It's unlikely the price changed. Okay, this morning I went to the machine, I bought to the supermarket, I bought some coffee. It always cost the same amount. It was in sale. So when I saw it, I didn't see it until I checked my ticket, and then I came back and I bought 20 units, okay, because there was a huge discount. I was almost inattentive. Usually I wouldn't even have noticed, but there was the discount and I noticed the discount, okay? So this is very common. It's also possible that these errors are just pure noise. I will have a video in the Moodle explaining that a bit more. But this is not always the case. There are these sort of biases, not pure noise, but a bias. So my choices are directed into one direction. For instance, the person who was gambling, it's not that sometimes gambles too much and sometimes gambles too little. He probably always gambles too much, okay? So that's not such a simple solution, okay? And then typically people, what they do is if you are thinking about gambling, you are going to have to introduce this into the model, okay? And they are going to have to depart from the rationality assumption. What is the problem of this? Well, we already saw it today. What was the problem I explained to you of letting this gambler choose different from what he wants? What was the predictive power? Were we able to say what was going to happen? No. It could be that he's better off with a tax. It could be that he's worse off with a tax. It could be that he buys more, he likes a bank. It could be that he doesn't like a bank. So our predictive power, our power to say things about what he wants or what are good policies is much more limited. And vice versa. You are actually going to be very difficult to say things about what she wants or what he wants. Because what you see him doing is not very informative about what he wants. So you are also not going to be very sure when you see him choosing whether you are able to tell what he wants, which in the traditional model you can. So when you give up on something, you give up on the assumptions of the classical model, you also lose on other things, in this case, on our ability to make predictions and ability to make inferences. Okay? So these are the reasons why, mostly it's a choice problem for you. If you are interested in studying some market, you have to ask yourself, how valuable, how good is the general model, the basic model to explain this market? Is this a market where I can expect people to behave according to this, and to what degree? And if it is good, then you should use it because it's a very parsimonious, strong predictive power, and very well understood model. And if not, then you should introduce something. You should explain why you introduce it, and you should know that the ability that you will have to make predictions and the ability that you will have to make inferences is much more limited. Okay? Good. So next week, we are going to move to On Thursday, we're going to move to to ask questions not about a single person, because in economics we don't care about a single person, but about groups. Okay, we are going to move to groups of people. Very bad.
את החדשות תוך כדי, אני מניח. ננסה רגע להבין את התמונה, כמו כל ההורים של כל ה...
לאירוע בכללי הייתי צריך לצאת מוקדם יותר. עדיין בחדר שינה בכלל?
לא יכולתי אפילו לשים את הטלפון השקט שלא יצלצל. אז
שקשה לתאר אותו, תוך כדי... חדשים, נטבחים, רגע ישבתי, הרגע רקדתי איתם, באורות, קולות, היינו באושר גדול. ואני... בגדול. בחוץ, אנשים מתים, חברים שלי נטבחים. חבר'ה שהרגע ישבתי, הרגע רקדתי איתם. כולם אוכלים עכשיו.
הלחימה בעצם מתקבלת, אנחנו מתחילים לשמוע אותם נכנסים. לבתים. אנחנו מתחילים לשמוע המונים, אנחנו מתחילים לשמוע את אלף. סנטי בשלב הזה, זה היה מאוד.
Test. Man hört nichts. Können wir den zweiten wieder aufschalten? Okay.
Also.
Wie viele Leute wartet sie jetzt? Wie viele Leute wartet sie?
Ich glaube, das war's.
Das war's?
Ja.
Ja.
35 Stück.
Wieso?
Ziemlich kleine Türen gehen auf.
Ja.
Haben die es bestimmt? Wie? Wer hat es bestimmt?
Ich.
Die beiden rumgegangen.
Achso.
Aber die haben es gemacht. Okay, Security hat sie bestimmt.
Ja.
Okay, intern?
Über die Uni, ja.